Let's start with launching the terminal app. It's located inside the folder Applications, Utilities. Double-click it and then you'll get the window which is basically empty. A terminal window simply shows a command line interface generated by a shell. In our case it's that shell. As long as you're in this window, you can largely forget about your mouse or trackpad, with a couple of exceptions. Everything you do here uses the keyboard only. Of course, the window isn't completely empty. The first line lists by default the date and time of your last login. That last part on TTY signifies the terminal interface with which you logged in the last time. It might say something different, such as on console or nothing at all. Now you can safely ignore this line. The second line is the actual command line, the line on which you type commands. It can be different if you are using bash rather than that shell. Either way, the rectangular box at the end is the cursor. You don't have to confuse it with pointer, which reflects mouse movements. Everything before the cursor is known as a prompt, which is to say it's prompting you to type something. The first part of the prompt, in the case of that shell, is my short username, followed by the @ sign and the name of my Mac. Next is the tilde, which signifies that I'm currently in my home directory, which for me is /users/shumi. And finally, the % signifies that I'm logged as an ordinary non-root user. That % and $character are equivalents. % character is for that shell and $character is for bash. We'll talk about these characters a bit later and about another character which signify the root user. By the way, you can change your computer's name in System Preferences sharing if you don't like how your command line looks like. Or better to say, prompt looks like. And remember that all these things are customizable. Now, although you are never required to use a mouse or trackpad in terminal, and all command line programs were designed to be used with only a keyboard, there are a few situations in which a pointing device can come in handy. First, you can use your mouse to select text, just as you would in any other Mac app. Then you can drag a file or folder in from the Finder to copy its path to command line, formatted in such a way that you don't have to worry about spaces or other reserved characters. You can also use your mouse in Nano Editor, in Nano Text Editor. You can option-click to move your cursor to that spot. And you can double-click an URL with Command button to open it in your default browser. You can also scroll through man pages and move the cursor up or down by line in programs such as Nano Text Editor. Now, before we proceed, let me show how to change your shell, in case you want to use bash shell instead of Z shell or ZSH. To do this, go to System Preferences, Users and Groups, then click the lock to make changes, enter your password in case you've got one, otherwise just click Unlock, press Ctrl and click your user. You'll get advanced options. Click on this link and then in this login shell, click the down arrow and select the shell you want to use. As you can see here, I don't have an option for bash shell, because in this latest version of macOS, which is Catalina, they switched from bash to Z shell as a default option. Now let's switch to the console window. and try to modify the window itself a bit. The window you're looking at is just like any other macOS window. You can move it, minimize it, resize it, zoom it, scroll through its contents, and hide it using the usual controls. So please do adjust it to your liking. However, I'd like to say that there are two important points about window modification. First, resizing isn't only a good idea, it's practically mandatory. Some commands you'll run in this window generate a lot of text, including some large tables, and you'll find it much easier to work in the command line if your terminal window is a bit bigger. So go ahead and make the window as large as you want. Second, any changes you make to the window ordinarily last only until you close it. So if you open a new window or quit terminal and launch it again, you are returned to the defaults. So once you get your terminal window to a size, shape and position you like, then choose Shell, use settings as default. Thereafter, all new terminal windows that you open use your preferred characteristics. By the way, if you want to fast enlarge your text, just press Ctrl and press plus button until the text is okay for you. Also, you can have as many windows open as you need for this terminal, and each with its own command line. To open a new window, just press Command and New, N. It will open the default window. When you open a new window in terminal, you begin a new session. That means another copy of the shell runs, separate from the first copy. You can run a program or navigate to a location in the first session and run a completely different program or navigate to another location in the second. The two sessions don't normally interact at all. Why would you want to do this? Perhaps you want to refer to a program's man or manual page in one window while trying out the command in a second. Perhaps one shell is busy performing some lengthy task and you want to do something else at the same time. Or perhaps you want to compare the contents of two directories side by side. Whatever the case, remember you are not limited to using one window or one session at a time. And by the way, every terminal window supports multiple tabs as well, just like most web browsers. So if you want to have multiple sessions, you can do it easily by pressing Command and T button, exactly as in a browser. And you can also drag tabs to rearrange them, close them individually, and even drag a tab from one window to another. Now, if you want to change the Windows attributes, you can always do this. You can change the background color and transparency, font, typeface and size, text color, cursor type, and numerous other settings. For starters, just to get a feel for what's possible, choose Shell, New Window or New Tab, and try some of the pre-built profiles, previously called themes. For example, choose Shell, New Window, Homebrew for a display with bright green text in 12-point Andale mono against a slightly transparent black background. Or choose Shell, New Window, Grass for pale yellow text with an opaque green background and with a red cursor. Of course, if you prefer to use one of these other profiles as your default, open a new window with that theme and choose Shell, use settings as default. But you can also modify these profiles or create your own. To modify your Windows appearance, follow these steps. Choose Terminal, Preferences, Profiles, select a profile in the list to modify it, or to create your own new theme based on an existing one. Select a theme and choose Duplicate Settings from the pop-up action menu at the bottom of the list and click the plus button to add your own theme from scratch. Then to modify the text and colors that appear in the window of the currently selected theme, click Text. You can modify background color, font, text color, and cursor attributes. You can also modify the window itself. To do this, click Window. Some options you can change here include title bar elements, window size. And as usual, to make a profile the default, which means it's used automatically when you launch terminal and when you press Command N. Then select it and click the default button beneath the list of themes. When you are finished adjusting Windows settings, close the settings window. Ready to start learning some commands? Here we go. Open a terminal window and enter this, pwd. As a reminder, to enter something on the command line, type it and then press return or enter button. The pwd command stands for print working directory, and it gives you the complete path to the directory you are currently using. If you haven't done anything else since opening a terminal window, that's your home directory. So you'll see something like this: /user/your username. In my case, it's Shumi. It's not exciting, but it's extremely important. As you navigate through the directory structure, it's easy to get lost. And ordinarily, your prompt only tells you the name of your current directory, not where it's located on your disk. When you are in a deeply embedded directory, being able to tell exactly where you are can be a huge help. Now let's see what's here. If you were in the Finder, you'd know exactly what's in the current folder just by looking. Not so on the command line. You must ask explicitly. To get a list, you use the list command and type ls. What you get by default is a list along the lines of the following. Items are listed alphabetically, top to bottom and then left to right. But as you can see, this doesn't tell you whether these items are files or directories, how large they are, or anything else about them. So most people prefer the more helpful long format by adding the -l flag. So let's type it, ls-l. This produces a result something like mine. Reading from right to left, notice that each line ends with the item's name. To the left of the name is a date and time showing when the item was most recently modified. To the left of the date is another number showing the item's size in bytes. Later on we'll go into more detail about the characters which occupy the first half of each line, such as this, D, R, W, X, R, and so on. Then my name and this stuff thing. But now look at one other number between the permissions and owner. For example, this number 4 or 5, that's the number of links to the item. And although links are too advanced to explain in detail here, the number serves one particular purpose. It gives you an approximation of the number of items in a directory. In fact, it is always at least 2 higher than the number of visible files or directories in the directory. For now, just know that the number can tell you at a glance if a directory has only a few items or many. Now, as I've mentioned, ls-l will provide the file size in bytes, which isn't convenient to tell the size of large files. For example, if the file is large, it will be very difficult to say it in megabytes. Luckily, you can improve on this by adding the -h flag, which stands for human readable, and type ls-lh. And now you can see the files and their sizes in megabytes. Also, it's worth mentioning that you can always list the contents of a directory other than your current one. You could type like this, ls and the path to this directory. For example, if you type ls followed by /, it'll reveal all the contents of the root directory. Then you could go ahead and add this etc directory to this path by typing ls/etc and so on. By the way, if you want to repeat a command you've just entered, it's not a big deal. You can use just these two keys, up arrow and down arrow keys, to move backward and forward through the list of commands you've recently typed. For example, if the last command you've typed was ls-lh, simply pressing up arrow key once puts that on the command line. Then to execute it, you would press return or enter. Keep pressing up arrow key and you'll step backwards through even more commands. You can even scroll through commands you've entered in previous sessions. And down arrow key works the same way. It progresses forward in time from your current location in the list of previous commands. Another handy way of repeating a command is to enter 2 exclamation points. So to repeat your previous command, just enter 2 exclamation points, and for example, if it was pwd, it'll repeat this command once again, and you'll get the same output. Again, this isn't terribly interesting when you're talking about short commands, but it can save time and effort with long commands. And the 2 exclamation points command need not stand alone on the command line, and you can add stuff before or after it in order to expand the previous command. For example, if you previously entered ls-l and you now want to add -h, you could type 2 exclamation points -h. Or for example, if you enter a command like rm file1 and you need some permission, some privileges to remove this file, you could type sudo followed by 2 exclamation points. We'll talk about this sudo command a bit later, but for now just know that this command allows you to get some privileges, some administrative privileges to perform some actions. Now, as you work in terminal, the output of earlier commands, such as file lists, scrolls upward, and you can easily accumulate many thousands of lines of output in a single session. To find some text within your current terminal session, without manually scrolling and looking for it, you can press Command key with F for find, and type a search term, and if necessary, press Command G for find next. Or optionally, you could just press return key to get to the next find result. To get out of this find in text window, just press escape key. Now, what if you type some stuff on the command line and realize you don't want to enter the command? Well, you could backspace over it, but that may take a while if there is a lot of text on the line. An easier way to back out of a command without executing it is to press either Ctrl+C or Command period. Now let's begin exploring directory structure of your system with the cd command. One of the directories inside your home directory is called library, so let's move there by typing cd library. Notice that library is capitalized here. Sometimes case isn't important on the command line, but you can go wrong if you always use the correct case. When you put a directory name after the cd command, it assumes you want to move into that directory in your current location. If there doesn't happen to be a directory called library in your current directory, you see an error message which will say no such file or directory. And as a reminder, the command line environment doesn't list the contents of a directory unless you ask it to, using ls. So using cd doesn't automatically show what is in your new location. You know the command succeeded if you don't see an error message. And by default your prompt includes the name of your current directory. Like this, if you can see on my prompt, after the name of the machine, I have this library directory name. Now that you are in the library directory, that's in your home directory, you can use ls to look around. You'll see that one of the directories inside the current one is preferences. So to move down a level into the preferences, you'd enter cd preferences, and so on. To go up a level, you use the ... convention, which means the directory that encloses this one. For example, if you are in users show me library preferences, the directory that encloses its users show me library. So in this particular location, 2 periods means users show me library. To get there, you enter cd followed by ... That translates as change directories to the one that encloses this one. You can keep going up and down with cd ... and cd directory, meaning cd the name of the directory, as much as you like. So moving into directories with spaces in their names requires extra effort. Nothing says that you have to move up or down just one level at a time. If you are currently in users and your name, in my case it's show me, and you know that there is a library directory inside it, and inside that there is a preferences directory, you can jump directly to preferences like so, cd library / preferences. The slash simply denotes that the term to its right is a directory inside the term on its left. Preferences is a directory inside library. You can add on as many of these as you need. For example, you could type cd library logs assistant analytics and so on deeper in the structure. And this also works in the other direction. You could type cd ... / and so on. And by the way, this sort of path is named relative path. Now, if you want to use the exact location and you know exactly where you're going, you can jump directly to any location on your Mac. Just specify the full path, beginning with a slash, which represents the root level of your disk. And this path will be called an absolute path. For example, you could type cd / etc, and that takes you directly to the /etc directory, without having to navigate all the way up to the root level of your disk and then back down, with all that dots. Now, speaking of the root level, if you want to go to the very top of your disk hierarchy, just enter cd /. And if you want to go back to the last directory you were in, just type cd --. For example, if you are now in the root directory and want to get back to the etc directory, just type cd - and you are back in etc directory. Once you've changed directories a few times, you may want to get back to your home directory. Of course, you could keep navigating up and down or directory at a time until you get there, but you could enter the complete path of your home directory as well. But there is an easier way to do this. Just type cd and tilde, or even easier one, just type cd and it'll get you to the home directory. And if you want to get to some subdirectory of your home directory, you could type cd tilde / and the name of the directory, for example, library. This will get you to the library directory, which is located in your home directory. Now some words about paths. You've already seen both relative paths and absolute paths. Relative paths such as library/preferences inside my current directory. And absolute paths will look like /library/preferences and before that /users/shumi. So the whole path will begin with / from the very root of your directory structure. Now some words about using tab completion. As you type lots of information on the command line, it can get kind of tedious spelling out file and directory name over and over again, especially since even the slightest typo can make a command fail. So shell include a number of handy features to reduce the amount of typing you have to do. Earlier I explained how to use the arrow keys and the exclamation mark command to repeat previous commands. Now I want to tell you about a different keystroke saving technique. It's a tab completion. Here is the basic idea. You start typing a file or directory name and then you press the tab key. If only one item in the current directory starts with the letter you typed, the shell fills in the rest of that item's name. If there is more than one match, you'll see a list of all the matches. For example, let's start typing cd and press tab, and you'll get all the options for completion. Let's say we want to change our directory to the well-known library directory. We'll start typing capital L and again press tab, and the shell will complete the directory's name for you. In this case, there is only one directory beginning with L. And if you've got several directories like desktop and documents, let's try typing cd capital D and press tab again. And the shell will show 3 different options like desktop, documents and downloads. So I'll type E key and press tab again. And the shell will complete the directory's name for me, as there is only one directory starting with capital D and E letters, and so on. You can press tab in any point of your path. For example, you could try typing cd / and capital L again, and press tab here. And on this point, the shell will complete your path. Then you could try typing capital F and A letters and press tab again. The shell will propose you 2 names, and if you add V letter and press tab again, it will autocomplete because there is only one option with these letters. In the command line environment, as in the Finder, you may not know where to find a particular file or directory. 2 commands can supply that information readily, namely find and locate. Each has its pros and cons. To use the find command, you give it a name or particular name to look for and tell it where to start looking. The command then traverses every directory in the area you specify, looking at every single file until it finds a match. That makes it slow but thorough. For example, suppose I want to find all the files anywhere in my home directory with names that contain the string makefile. After the command find, the tilde tells the command to begin looking in my home directory. Then I add the temp directory in which I'll be looking for this string. The -name flag says to look for patterns in the last item of a path, which may include the names of directories as well as files. I put the search string inside quotation marks with the asterisk wildcard at the beginning and end to signify that there may be are the letters before and after keychain. Even a simple search such as this one can take several minutes because it must look at every single file, starting at the path I specified. To make it go quicker, I could specify a narrower search range, for example, to look at only in my temp directory, as I've done. But if I didn't specify this and was looking all over the home directory, it'd take much more time. Let me offer a few other tips for using find. To search in the current directory and all subdirectories, use a period as the location. So you could type find period dash name and the string you are looking for, like Mac with asterisks and double quotes. To search your entire disk, use a slash as the location. So you could type find / name and again the string. Normally find is case sensitive, so a search for Mac string would not match a file named Mac with capital M. To make a search case insensitive, replace -name with -iname, as in find ~-iname and the string you are looking for. During a search, if find encounters any directories you don't have permission to search, it displays the path of the directory with the message permission denied. To search this path, use sudo before find. We'll talk about sudo a bit later. Now, if you want to search the contents of files, you should instead use the grep command, though this process usually takes much longer. Another useful command is locate. Unlike find, locate doesn't traverse every file to find what you are looking for. Instead, it relies on a database of file and path name. The benefit of using the index is that locate is very fast. The downside is that database is normally updated only once a week, so locate may be unable to find files you've added or renamed recently. So to use locate, just type that command followed by any portion of file name you want to look for. For example, locate Mac file. Like find, locate performs case-sensitive searches by default. To make a search case insensitive, add the -i flag. So you could type locate -i Mac file. If you enter locate and get an error stating that no database exists, or if it exists but is outdated, you can create or update it by entering this -usr -lib exec -locate.update db. This will take some time if you haven't updated for a long time or running this for the first time. And also please note that locate indexes only files you own, mostly the contents of your home directory. However, if you run the database updating script using sudo, it indexes every file on your disk, and locate can therefore find every file. You may not read a lot of plain text files in the Finder, but the need to do so comes up more frequently in the command line environment. Reading documentation, examining programs' configurations, viewing shell scripts, inspecting logs, and numerous other situations. You can use many tools to read a file. So let's start with more or less. An early Unix program for reading text files was called more. It was pretty primitive and wouldn't let you move backward to see earlier text. So a new program came along that was supposed to be the opposite of more, which is less. In MacOS, both names still exist, but they point to the same program. Whether you enter more or less, you're actually running less. So let's try reading a file which I've got in this temp directory, which is called textfile1.txt, and I'll type less textfile1.txt. Remember, this is a relative path to this file. If you'd like to type the absolute path to this file, you'd do like so. /users from the capital U /show_me/temp/text file.txt. And to exit from less reading mode, just press escape. Again, to see the top portion of the file initially, you can scroll down a line at a time using the down arrow or up arrow key. Scroll ahead a screen at a time by pressing the space bar, or backward a screen at a time by pressing the B key. As I've said, to quit less, press Q key or escape. Another command is cat. It is short for concatenate. Combines files, but also can be used to display a text file on your screen. Unlike less, it doesn't give you a paged view. It simply pours the entire contents of the file, regardless of length, onto your screen. You can then scroll the terminal window up and down as necessary to view the contents. So let's type cat and the file name again. If you open a long file with less, it can take quite a bit of tapping on the spacebar to reach the end, which is awkward if the information you want happens to be at the end, as is in the case with logs. And if you use cat, it can clutter your terminal window with lots of information you don't need. So to jump to the end of the file, of the text file, use a different program, which is tail, which displays the tail end of a file. If you enter tail followed by the file name, it displays the last 10 lines of the file. And if you want to view just some number of lines, for example 2 lines, you could add a flag which is -n and a number of lines. For example, let's type tail -n2 and the file name. So it will dump 2 last lines of my small file. But if it were very long log file, it is very convenient to use this command. On the opposite, there is a head command. Sometimes you may want to look at the beginning of a file instead. For that purpose, you use this program head. If you enter head followed by the file name, it displays the first 10 lines of the file. And again, you could use the -n flag to specify the number of lines you want to view. For example, head -n2 and the file name itself. Let's talk about copying files and directories. The copy operation duplicates a file or directory. There is a single command called cp that is used for this purpose. The cp command copies one or more files to either the current directory or another. If you want to duplicate a file in the same directory, you must give a different name to the target file. If you want to copy a file to a different directory, you can use the same file name or different. Consider the following examples we will use right now. To copy file 1 as new file 1 in the same directory, we will use cp command. Let's type cp file 1 and then followed by new file 1. To copy file 1 by the same name to another existing directory, called dir1 for example, we will use cp file 1 and then the name of the dir you want to copy to. In our case it's dir1. By default, the copy operation overrides the destination if it exists without giving a warning. Use the I option to instruct -i option to instruct the cp command to prompt for confirmation before overwriting. So let's type cp-i file 1 dir1. Also note that by default you do not need to specify the -i option for yes or no confirmation if you are attempting to copy a file to override the destination file as a root. There is a predefined alias cp equals in quotes cp-i in the root users .bash rc file that takes care of that. Now you can copy directories with cp command either. The cp command with the -r or recursive option copies an entire directory tree to another location. In the following example, which we'll use, we will copy one directory to another new directory. So let's copy with cp command -r, that is for recursive, and we will copy dir1 to dir1 copy, for example. That will recursively, as I said, copy all the files in dir1 to dir1 copy folder. And again, you may want to use the -i option for override confirmation. What about moving and renaming files and directories? A file or directory can be moved within the same file system or to another. Within the file system move, a corresponding entry is added to the target directory and the source entry is removed. In this case, the actual data remains intact. On the other hand, a move to a directory file system physically moves the file or directory contents to the new location. A rename simply changes the name of a file or directory. Data is not touched. The mv command or move command is used to move or rename files. The -i option can be specified for the user confirmation if a file by that name already exists. Let's move file 1 to dir2, for example. We will type mv-i file1 and then dir2. And again, by default, you do not need to specify the -i option if you do this with root. To rename, for example, new file as new file1 or new file2, you can use this command as well. We will type move new file and the new name for this file, new file1. And again, you can use the option -i with move command if needed. To move a directory along with its contents to somewhere else or simply change the name of the directory, use move command as well. For example, to move dir1 to new dir1, for example, use the following command mv dir1 and the new name for it, new dir1. Now, if you want to remove files and directories, there are some commands for that either. The remove operation deletes a file entry from the directory structure and marks its data space as free. For a directory, deletes corresponding entries from the file system structure. You can remove a file using the rm command or remove command, which deletes one or more specified files at once. Let's remove new file. For this we type rm new file. The -i option again can be used to prevent accidental removal. The option instructs the command to prompt for confirmation before proceeding with the removal. And again, remember about this -i option for the root user. As for directories, there are two commands available to remove directories, which we'll use right now. That is, use rm command which with the -r switch to remove a non-empty directory. And if you want to remove an empty directory, just use rmdir for these purposes. And again, remember about -i option. In this lesson, we will talk about finding files and directories in your operating system. For these purposes, we could use two commands, find and locate. With find command, you could supply your search criteria, and this command gets you the results on the screen or redirect to a file. You can also instruct this utility to execute a command on the files as they are found. The find command recursively searches the directory tree, finds all files that match the specified criteria, and optionally performs an action on the files as they are found. This powerful tool can be tailored to look for files in a number of ways. The search criteria may include tracking for files by name, ownership, owning group, permissions, inode number, last access modification time, size and file type. Let's take a closer look at find command syntaxes. First we type the command itself, find. Then we type path in which we will be looking for some files or directories we are in need. This could be your current directory which we are using. This could be /etc or /var directory or some other directory which you are in need. Then you have to type search option. You could search by several criteria. You could search by name, by user ID, group ID, permissions, inode, access time, modification time, size or type. For all these criteria we have options. For example, for name we could type -name. For user ID we could type -user. For permissions -perm. And for size we could type -size or -type for type. And the last part of the command is action. For example, you could perform some action after having found the files or folder you need. For example, you found some files, then you could delete all these files, or you could modify permissions on all these files. And this is very powerful tool, find command. Now let's take a closer look at using some examples which could be practical for you. For example, if you want to find a file which is named like file1, you could use find command find dot means that you are looking at the current directory, then -name and then file1. So let's type it. Let's type find dot -name file1, and that finds the file with this name in the current directory. To find some files like file1 again in some specific directory, you could type find /home /home/temp. That would be the path in which we will be looking for the specific files, then -name and file1 again. On this path name, you could specify any path you are in need currently. If it's necessary for you to find files which use both capital and small letters, you could use -iname parameter, and that will find all the files which are insensitive to cases. So let's type the following example file, and we will be looking in our home directory, so we will type -iname and file. Now, if you need to find directories, you could use -type parameter, so you could type -type d. That will mean that you are looking for directories. Let's type find dot -type d -name dir1. That will find all the directories which contain this name in it. The same option works for files, but you have to specify instead of d, f letter that will specify that it will be type f. It will be for files. So let's find all files with the name text1.txt in the current directory. For this we will be using find dot -type f -name text1.txt. If you want to find all the files with txt extension, you could specify it in quotes, but instead of the file's name, you should type quotes *txt close quote. That will find all the files with the .txt extension in this directory. Another good example is to find all the files with some specific permissions. For example, to find old files with 0777 permissions, you could use find dot -type f -perm 0777 and that will find all the files which contain the following permissions. If you want to find all the files not with such permissions like 777, you could specify exclamation mark before perm parameter. So you should type find dot dash type f exclamation mark dash perm 777. Now, if you wish to do something with the results which the find command found for you, you could add -exec parameter and then add the command you want to run. For example, if you want to change all the permissions from 777 to, say, 644, you could add to this previous command -exec change mode 644 curly brackets backslash and semicolon. This will change all the permissions from 777 to 644 on all the files which find command found for you. You could also, for example, delete all these files. In this case, you will have to add -exec rm command -f and again curly brackets backslash and semicolon. You could also try finding all the files which have, for example, txt extension and remove them, or some other extensions, or search criteria which you are in need right now. Now, if you want to find all empty directories or files, you could also do this with find command. Let's try typing find dot dash type f dash empty. So this will find all the empty files in this directory which we are right now. The same goes for directories, but instead you should try typing dash type d dash empty, and that will find all the empty directories in your working directory. Another criteria that could be of use, finding all hidden files. For this we should type find dot dash type f dash name, and in quotes we should type dot asterisk and close quotes. If you want to find some file which has an owner of some other user, or files created by some other users, you could specify it with -user criteria. So let's find all files which were created by user root. For this we type find dot -user root -name, and then in quotes asterisk sign. That will find all the files which were created by the user root. If you want to find all the files which belong to some specific user, you could do this by typing find. For our case, it's we are looking in our working directory. We will type dot -user temp. That will find all the files which belong to the user temp. Another useful example is when you want to find some files which were modified some time back. For example, to find all files which are modified 7 days back, you could use the following command find dot -mtime 7, and it finds all the files which were modified 7 days back. To find files which are accessed 7 days back, you could use the following command find dot -atime 7, and it finds all the files which are necessary for you. You could sum up this criteria by typing find dot -mtime plus 7 -mtime minus 20, let's say 20. That will find all the files which are modified more than 7 days back and less than 20 days If you want to find all the files which are changed in last, let's say, 1 hour, you could use find-cmin -60. That will find all the files which were modified in the last 1 hour. Sorry, that were changed in last hour. And the files which were modified in last 1 hour, you should use -mmin -60. This will find all the files which were modified in the last 1 hour. Pretty much the same with accessed files. For example, if you want to find the files which were accessed in the last 1 hour, you should use -amin parameter, and that will find all the files which were accessed in last 1 hour. And another useful parameter is -size. With -size parameter, you could find the files which are more than specific size or less than specified size. So if you're looking for the size which is more than, let's say, 10 megabytes, you could specify plus 10 megabytes. If you are looking for the size which is less than 10 megabytes, you could specify minus 10 megabytes. And again, you could add exec parameter -exec, and then, for example, remove all the files which are less than 10 megabytes. So that will be, the syntaxes will be -exec rm -rf curly brackets / semicolon. Some words about locate command. It's also very useful and handy to find files and directories. But on Red Hat Linux you have to install it first. For this we will run yum install mlocate package. This will install the package, and after it is installed we need to update the database with the command update db. So we will run it. Let's type update db. And when the updating is done, you could use this command. Let's create some file here in our working directory. Let's say we will create with touch command file1, and after that we will try to find it with locate command. Let's type locate file1, and it easily finds the file. Locate command is more robust and quick than find command because it keeps database and finds files easily and fast. Now let's review some examples using mlocate or locate command. As I said, if you want to find some file or directory with some specific name, you just type locate and the file's name, like I did, locate file1. And it found all the files on the system. If you want to limit search queries to specific numbers, you could do this with -n parameter. For example, we could type locate dir with asterisk, so we will be looking all the files containing dir in it, and then -n and let's say 10 results. We need 10 results for this search. If you want to display the count of all matching entries of dir, use the locate-c command. Let's type locate-c dir asterisk, and it shows all the results matching and the count for these results. Again, it can find case insensitive. For this you could specify -i parameter, and that will find all the results disregarding case sensitivity. As I said, locate command relies on a database called mlocate. For this you have to regularly update this database to run this command efficiently. So you could add cron job for updating this database regularly, not to do it manually. For this, of course, you have to have sudo privileges or super user privileges or root privileges. You could check the current status of your mloc database with -S command. Let's run it. locate-S will show us the information on the database we currently have on our system. And of course, you could move your mloc database to some other than default location with locate-D. Then you have to specify new DB path and the file name. I won't do this because I don't need it, but you have to know that you could do this if needed. Some words about file system security or access rights. In your home directory, type ls-l for long listing. You will see that now you get lots of details about the contents of your directory. Each file and directory has associated rights, access rights, which may be found by typing ls-l. Also, ls-lg gives additional information as to which group owns the file or directory. In the left-hand column of a 10-symbol string consisting of the symbols D, R, W, X, dash, and occasionally S or capital S. Now, if D is present, it will be at the left-hand end of the string and indicates a directory. Otherwise, dash will be the starting symbol of the string. The 9 remaining symbols indicate the permission or access rights and are taken as 3 groups. The left group of 3 gives the file permissions for the user that owns the file or directory. The middle group gives the permissions of the group of people to whom the file or directory belongs. The rightmost group gives the permissions of all others. The symbols R, W, etc. have slightly different meanings depending on whether they refer to a simple file or to a directory. Now let's switch to access rights on files group. R or dash indicates read permissions or there is no read permissions. That is the presence or absence of permission to read and copy the file. W indicates write permission, or if we have dash, that is, there is or there is no a permission to write or change a file. And X indicates execution permissions, that is, the permission to execute a file where appropriate. And the last one is access rights on directories. R allows users to list files in the directory. W means that users may delete files from the directory or move files into it. And X means the right to access files in the directory. This implies that you may read files in the directory provided you have read permission on the individual files. So in order to read a file, you must have execute permission on the directory containing that file. And on any directory containing that directory as a subdirectory. And so on, up the tree. For example, -rwx rwx rwx. This is a file that everyone can read, write, and execute and delete. And if we have -r, w and all dashes, a file that only the owner can read and write, no one else can read or write, and no one has execution rights. For example, your mailbox file. Now let's move on to changing access rights. Change mode or changing a file mode will help us in this. Only the owner of a file can use change mode to change the permission of a file. The options of change mode are as follows. U stands for user, G stands for group, O stands for other, A stands for all, R for read, W for write and delete, X for execute and access directory, plus add permission, minus take away permission. For example, to remove read, write and execute permissions on the file example, for example, I don't know, file permission, let's call it. And for the group of others, type change mode go-rwx and permissions file. This will leave the other permissions unaffected. To give read and write permissions on the file permissions to all, let's type change mode a plus rw file permission file. Now a task for you. Create some file and name it and try changing access permissions on the file and on the directory it is in. Use ls-l to check that the permissions have changed. You can pause here and get back to this lesson later when you are done with your task. Now I hope you have performed this simple task, and now let's switch to processes and jobs. Let's create a directory with make directory command. We will create a directory in our home folder and name it adir. And let's create a file with touch. Let's create a touch a file and do some activities with these two items. Let's type change mode 0700 and the name of the directory adir. Let me list this adir directory with ls command ls-la adir and check the permissions for now. The directory's owner can read and or write files in that directory as well as change it. All other users except root have no access. Now let's run change mode 0711 to the adir. Let's list it again and check the permissions. Same as for the owner, all other can change to the directory, but not view or change files in the directory. This can be useful for several situations where you prevent someone from listing directory contents but allow access to a file in the directory if someone already knows it's there. Other permissions with change mode go plus r and adir name. Let's list it again and review the permissions. It has added read permissions to a directory. Let's use change mode again. We will type change mode 0777 and the directory name adir in our case, or we could type it as change mode a equals rwx and the directory's name adir. This gives all permissions to this directory. They are wide open. Let's list the directory again. Now let's type change mode 0000 for zeros and the directory name adir. Another way of typing is change mode a minus rwx and the directory name adir. In this case, all permissions are closed. It's good to protect a directory from errant changes. So if you don't want any changes to this directory, we could use this permission. Now let's type change mode and 36666 and now we will apply it to the file, a file. Let's list the permissions for a file with ls-la and file name, in our case it's a file. These permissions open read-write permissions completely on this file. Let's perform another command, change mode go minus rwa file. Let's check the file again with list command, and we can see that it doesn't let anyone except the owner to view, change or delete the file. change mode 644 a file, and in this case let's list it. In this case only the owner can change or delete the file, but all can view it. Now let's review the permissions, and let me append some useful information about dash capital R. Dash capital R option is handy feature of the change mode command. With dash capital R you can recursively change permissions on all files and directories starting from a point in the file system. For example, sudo change mode dash capital R 700 for ADIR will open permission to owner below ADIR directory. Sudo change mode dash R 000 ADIR will close all permissions below ADIR directory. And sudo change mode dash R A plus RWX ADIR will open all permissions below ADIR directory. And dash capital R option is inclusive. It means that this option will change the permissions for the ADIR itself, not only for the files and directories below this directory. Now let me add some more information about umask command. This is permissions given to a file or directory are assigned originally at the time that item is created. And how those permissions are set is based on the user's current umask value. Using the umask command you can set the permissions given to files and directories when you create them. For example, on this table you can see how different umask commands could be used for your purposes. Like umask 0066 will make directories as follows, and umask 0077 will make directories like this. So you could use this table for your future activities concerning permissions, and this is very handy command umask. You can also change ownership for the files and directories. When you create a file or directory, your user account is assigned to that file or directory. So is your primary group. As root user, you can change the ownership of this file or directory, and group assigned to a file to a different user or group using the change own command and change group commands. So on this table you can see the example of how you can use this change own command and change group command. The recursive option to change own, that is dash capital R, just shown, is also useful if you want or need to change the ownership of an entire directory structure. As with change mode, using change own recursively changes permissions for the directory named and along with its contents. You might use change own recursively when a person leaves a company, for example, or stops using the service. You can use change own dash R capital to reassign their folder to someone else. Now, if you want to find some words or some data, some phrases in the specified file, you can search for these words with grep command. Grep commands looks for the requested words or phrases. Now let's try to run this command. But first let's find out what word we will be looking for. Let's more etc logrotate.conf, and let's say we are looking for word monthly in this document. So we can use grep, then specify the file's name. In this case it's etc, then specify the word we are looking for, and the file's name etc logrotate.conf. And it gives us the result that word monthly was used twice. But if we want to find the lines in which were this word used, we can use -n option, and this will give us the lines, and -c will give us how many times it was used in this file. And -v will give us the result of the lines in which this word wasn't used. And in this case we can again use pipe more to see all the contents of the file. With more we can read more than one display. Another useful command is word count. To count words in some documents you can use this command, wc. wc will have also several options, but first you could use help wc and see what options do we have. wc-w will give you words, count of words. -m will give you characters. So let's run it with w option. Again we use this file etc logrotate.conf. That could be any file which you need to know how many words in it. So as you can see 114 words in this document. And how many lines? Let's check it. -l will give us the number of lines, 33 lines in this document. When you type cat command and don't specify a file to read, it reads the standard input, the keyboard, and on receiving it, it redirects it to standard output. In this case it's display. To end typing you can press Ctrl D. This will end reading the input. Let's press Ctrl D to finish this operation. Now if we want to redirect standard input into standard to not standard, sorry, output, as you know it is screen, we have to specify a file's name and greater than sign. That will create this file and redirect all the that is written to standard input to this output file. Let's call it output redirection, and now we have created this file. Let's check it. Let's list the directory. Here it is. Let's read the contents of this file with a cat command. Again, we can use it to read this file. Here it is, all the text which was added to standard input now is there. If you want to add some additional information, some additional data to this file, you can use two greater than signs that will add the additional contents to this file. Here it is, 5678, which was the latest update to this file. Now let's create another file. We will call it output redirection 2. type something here to check another option, which was the primary option, the primary intent of this cat command. It concatenates or joins two files together. So the first purpose of this command to join several files, the contents of several files, to one file. You have to specify these files, as in this case file 1 and file 2, and specify the new file. And greater than sign will create this new file. Let's check it. Cat new list will show us the contents of two files. It joined these two files into one file. Processes. A process is a unit for provisioning system resources. It is any program, application, or command that runs on the system. A process is created in memory in its own address space when a program, application, or command is initiated. Processes are organized in a hierarchical fashion. Each process has a parent process, also known as colon process, that spawns it. A single parent process may have one or many child processes and passes many of its attributes to them at the time of their creation. Each process is assigned a unique identification number, known as a process identifier, or PID, which is used by the kernel to manage and control the process through its life cycle. When a process completes its life cycle or is terminated, this event is reported back to its parent process, and all the resources provisioned to it are then freed, and PID is removed. Several processes are spawned at system boot, many of which sit in the memory and wait for an event to trigger a request to use their services. These background system processes are called daemons and are critical to system operability. Some words about viewing and monitoring processes. An operational system may have hundreds or thousands of processes running concurrently, depending on the purpose of the system. These processes may be viewed and monitored by various native tools such as PS or process status and top. The PS command offers several switches that influence its output, whereas top is used for real-time viewing and monitoring of processes and system resources. The PS command, without any option or arguments, lists processes specific to the terminal where this command is run. Let's run this command typing PS. This output shows basic process information in 4 columns. It shows PID in the first column, the terminal the process belongs to in the second column, the cumulative time the system CPU has given to this process in third column, and the name of actual command or program being executed in the last column. Some common options that we may use with the PS command to generate desired reports include -A, it means all, -E, it means every, -F, it means full format, and -L, it means long format. A combination of E, A, capital F, L options can produce a very detailed process report. However, it may or may not be useful in normal circumstances. There are a number of additional options available with this. You can check the man pages for details and usage. Let's run the following command: ps-eaf. The output of this command is spread across 8 columns that show details about every process running on the system. Let's take a closer look at these columns. UID, it means user ID or name of the process owner. PID, it means process ID of the process. PPID, process ID of the parent process. C colon shows processor utilization for the process. S time, process start date or time. TTI, the terminal on which the process was started. Console represents the system console and represents a background process. Time, it's aggregated execution time for the process, including time spent in both userland and kernel space. And the last column is CMD, the name of the command or the program. This PS command output indicates the presence of several daemon processes running in the background. These processes have no association with any terminal devices, and that is why they show question mark in the TTI column. Notice that PID and PPID numbers. The smaller the number, the earlier it is started. The process with PID 0 is started first at system boot, followed by the process with PID 1, and so on. Each PID has an associated PPID in the third column. The owner of each process is shown in the UID column, along with the name of the command or program under CMD. Information for each running process is kept and maintained in the /proc file system, which PS and other commands reference to obtain desired data for our viewing. The other popular tool for viewing process information is the top command. This command displays the statistics and in the real time and may be helpful in identifying possible performance issues on the system. We will review this command in the following lesson. Though the tools we've discussed in the previous lessons provide us with a lot of information about processing, including their PID, Red Hat Enterprise Linux offers a PID of and pgrep commands that only list the PID of the specific process. These commands have a few switches available to them. However, their simplest use is to pass a process name as an argument to view its PID. For instance, to list the PID of the cron d daemon, use the following command: PID of cron d or pgrep cron d. Let's type these two commands in command line: PID of cron d and pgrep cron d, or you could type cron and asterisk character. You could also list process by user and group ownership. A process can be listed by its ownership or owning group. We can use the ps command for this purpose. For example, to list all processes owned by root, specify the -U option with the command and then the username. Let's run it: ps-U root. The command lists the PID, TTI, time, and process name for all processes owned by the root user. We can specify the -G option instead and the name of the owning group to print processes associated with the group only. Let's type ps-G and the name of the group. In our case it will be again root group. The process changes its operating state multiple times during its life cycle. Factors such as processor load, memory availability, process priority, and response from other applications affect how often a process jumps from one operating state to another. It may be in a non-running condition for a while or waiting for some other process to feed it information so that it can continue to run. There are 5 basic process states. Let's list all 5 states. The first state is running. The process is being executed by the system CPU. The second state is sleeping. The process is waiting for input from a user or another process. The third state is waiting. The process has received the input it was waiting for and it is now ready to run as soon as the turn arrives. The fourth state is stopped. The process is currently halted and will not run even when its turn comes, unless a signal is sent to it to change its behavior. And the last state is zombie. The process is dead. A zombie process exists in the process table alongside other process entries, but it takes up no resources. Its entry is retained until the parent process permits it to die. A zombie process is also called a defunction process or defunct process. Command chaining operators. Command chaining operators can help you much while running commands. Remember ampersand operator, so we used it to background some job. We just type a command and then ampersand operator and the command runs in background. You can also execute more than one command in the background in a single go. Run one command in the background, then you can type, for example, one command ampersand another command followed by another command and again ampersand. This will run these 2 commands in the background. Another good to know operator is semicolon operator. Semicolon operator makes it possible to run several commands in the single go and the execution of command occurs sequentially. Let's try type ps semicolon ls semicolon e and pwd. The result is that the first command to execute and then we execute the second command and the third command in one line. Next operator is AND operator. The AND operator, you type it like this, would execute the second command only if the execution of the first command succeeds. So it won't execute the second command if the first command fails. The exit status of the first command has to be 0 or a success status. This command is very useful in checking the execution status of last command. For example, we want to check file.txt with file command, and only if this command runs successfully and we can check this file.txt and this file exists, then we perform the second command and can read it with cat file.txt. So now let's run this command file1.txt and then type AND operator and then let's try to read it with cat command. So as you can see, it fails because file1.txt doesn't exist. Now let's perform this operation with existing file. Let's type file.txt AND operator and cat file.txt. It runs because the first command is successful, then the second command runs as well. OR operator. The OR operator, it is type like double pipe. is much like the else statement in programming. The above operator allows you to execute second command only if the execution of first command fails. So again, with our previous example, let's try to run file1.txt or cat file1.txt. In this case, it will run because, the second part of this command will run because the first command fails. Not operator. It is typed with exclamation mark. The not operator is much like an except statement. This command will execute all except the condition provided. To understand this, let's create a directory test and cd to it. Now let's create several files in this directory with touch command. Let's type touch file1.doc, file2.doc, file3.pdf, file4.xml, and file5.html, and file6.html. Now, to create all the files in this directory except PDF, let's say we don't want to remove all the files in this directory except PDF. Let's say we don't want to remove these files. We can type rm-r exclamation mark open brackets *.pdf close brackets. Let's check it with the ls command. And or operator. A good example is to check some host and pin it. If pin is up, you just have to echo that the host is up, and if the host is down, please echo host down. Let's try to pin some host, for example, pin-c 3 hops to www.go.com and echo up. Or if the host is down, echo host down.